Now we're gonna solve the following radical equation. Before doing so, we need to find where the values of the equation are gonna be. This is very important. We can't just square or multiply or do all the steps and keep going without any restrictions. We need to have restrictions. The first one is the domain of definition of this function. This is a function. So if you have something like 5, x is 5, you have the square root of -1, it's undefined. Okay? Here, if you have x is -3, okay, you have the square root of -2. You can't have it. So we are solving here for reals. We don't want to do this one for complex numbers. Okay? Sometimes we have applications where we have to find the solutions for the reals. We don't want it complex. Okay? If you need complex number, check my other videos. But for us now, we want to solve for just the reals. And we don't just come here and square or multiply. No, we need to see what these values are defined. The first step is we need to have 4 minus x greater or equal than 0 and x plus 1 greater or equal than 0. These two conditions, the first one will give us that 4 is bigger than x. That means x is less than 4. The second one is going to give us x is bigger than -1. So let's do our line, okay? So here we have 4, 3, 2, 1, 0, -1. Okay. So the first condition tells us that all the x's that will satisfy this equation will be less than 4. Okay. The second condition tells us that the x values are bigger than -1. So this is -1. So here, bigger than -1. Where these two intersect? In this interval. So our solution, x must be in this interval, -1, 4. Okay? We can also see clearly that 0 is a solution, because if we plug 0 here, why I'm saying that it's 0 is a solution, because sometimes you see the solution and it can be the only one. Okay, you should teach yourself how to see the solutions. So if you plug 0 here, you get square root of 4 is 2 plus square root of 1 is 1, which is 3. Another thing is, notice that if you have x as 3, so 4 minus 3 is 1, square root of 1 is 1, plus square root of 3 plus 1, which is 4, which is 2. So 1 plus 2 is 3. So we found just by examining this equation that we have two solutions, 0, 0 and 3. Are these two the only ones? Let's see. Let's do the algebra. So now, given that x in this condition, we can square here, we can multiply with no problems. We are not going to have problem of definitions. So let's do it. Let's square both sides. Squaring both sides, we get 4 minus x plus 1 plus 2 square root of 4 minus x plus 1 equals 9. So if you don't see it quickly, this is our a, this is our b. So I did a plus b squared, which is a squared plus b squared plus 2ab. Okay, a is square root of 4 minus x, b is square root of x plus 1. So I get to this result. Okay, now let's do some simplification. Minus x is gonna go with x, and 4 plus 1 is 5. We take it to this side, it's gonna give us 4, and we divide by 2, we get 2. So we have square root of 4 minus x times x plus 1 equals 2. Okay? So now when we square here, we're not gonna have the absolute value, because we know this one is positive because it's in this interval. So we have 4 minus x times x plus 1 equals 4. I squared both sides. Now let's expand this one. We're gonna have 4x plus 4 minus x squared plus x equals 4. So let's get rid of this one, and we have 5x minus x squared equals 0. Let's factor by x. No, let's be see 4. No, it's a minus x here. Sorry. So it's 4x plus 4 minus x squared minus x. So I have 3x here. Sorry. So 3x minus x. So I can factor. I get x 3x minus 1 equals 0. 3 minus x. Sorry. 3 minus x is 0. So I get x equals 0 or x equals 3. Okay, and we checked before that these two, x equals 0 and x equals 3, are the only solution, okay, of this equation. Okay, how can we solve it? Is there any other way? Yes, there is one more way to do it. Okay, so we can, okay, we know the square root of x is like this. So this is 1. Okay, square root of x plus 1, it's this one shifted 1 unit. Okay, so it's gonna be parallel to this one. So this is square root of x plus 1. Okay, minus square root of x 4 is this one here. It's gonna be on. It's gonna be 1 2 3 1 2 3 4, and this is 2. It's gonna be something like this. Okay, and you can graph them and see the solution.